Today we're going to prove the theorem that if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Notice here we're saying that we've got angle A is congruent to angle C, and angle B is congruent to angle D. And with that, we're going to prove that line AB is going to be parallel to CD, and BC is going to be parallel to AD. And essentially, opposite sides of a parallelogram are congruent. So that, if we prove this, then we have proven that it's a parallelogram. First thing, of course, we go ahead and write down the given, that the lines are congruent. And if they're congruent, we know that their measure is going to be the same because of the definition of congruency, all right? And we know that also, in trying to find a strategy to how to be able to prove these lines are parallel, we know we can either use like alternate interior angles, consecutive interior angles, and in this case, it looks like consecutive interior angles is going to be our path to solving this. We know that we add all the angles up around the quadrilateral, that's going to equal to 360 degrees. So I've got the measure of A is equal plus B plus C plus D equals 360. And so the sum of the angles of a quadrilateral are 360. Or remember the formula of the number of sides minus 2 times 180. Next, we know that if I go by substituting, I know that I've already figured that the measure of A is equal to the measure of C, and the measure of B is equal to the measure of D. So for A over here for C, so I can substitute in here for this point right here. Likewise, if I use angle C plus angle, I'm substituting C in here for A, all right? So in both of those cases right here, that's the case of substitution. Now I add these, the A's together and the B's together, and end up with the measure of 2 angle A's is plus the measure of 2 angle B's is equal to 360. Likewise, the angle of 2 measure C's plus 2 measure B's are going to be equal to 360. With that, then I go ahead and divide both of those by 2 on each side. Using division, we'll end up with A plus B equals 180, and C and B are equal to 180. So therefore, if they're equal to 180, we know by the definition of supplementary that these 2 angles are supplementary. So A is supplementary to B, A to B, and B to C. If that is the case, then, which we already know that is the case, then we know that these lines are parallel, because if we have consecutive interior angles are supplementary, then the lines are parallel. And therefore, we have proven up here, again, the theorem, if we got both angles of opposite angles are of a quadrilateral congruent, then the quadrilateral is a parallelogram.